I'm sorry I can't be there today, but well, Miss Bello is there for you. So I'm going to try to use this tool that is the one that Mr. Mendes uses to make his videos. So let's try, okay? Today we were supposed to see inequalities involving absolute value. I'm not sure about the page, and I'm not sure either about the section of the chapter, because I'm using right now the online version of the book, so you know that version is a little bit different from the one you have. Okay. Inequalities involving absolute value is basically a compound inequality. That is what we saw last class. Remember that we need to graph two inequalities in the same number line, and you're going to have two types of inequalities. One is the OR type, and the other one is the AND type. And here you have an example. When you have two inequalities graphed in the same number line and they're like this type, you have x less than -3 and x greater than 3, so you graph it like this. Remember that this open circle is because in the solution is not included the -3 and it's not included the 3. That's why you graph an open circle. So this type of inequality is called an OR type, and this type of inequality is called an AND type. Why AND? Because the solution set is going to be where both of them meet. In this case, x less than 3, so it's less than 3 open circle, because 3 is not included in the solution because it doesn't have the equal line here, and less than 3, and then x greater than -3. So the place where both of them meet are here inside this rectangle here. So this inequality is called an AND type of inequality. So in this example on the book, we have the example of x equals x, absolute value of x less than 3. First of all, we need to remember what absolute value is. Absolute value is a distance. And because it's a distance, it cannot be negative. That's why when we find an absolute value, like this example here that we have absolute value of x, when we take the bars of the absolute value, we can have or positive x, or we can have negative x. Why? Because if I have absolute value of x or absolute value of negative x, at the end, both of them are going to be x. I know you'll see it better with a number. For example, if you have absolute value of 4 is 4, and you have absolute value of -4 is the same, is 4 too. Why? Because the distance from 0 to 4 is 4. Picture a number line. The distance from 0 to 4 is 4. And same number line. Picture the distance from 0 to -4 is going to be 4 too. That's why if we work with an inequality involving absolute value like this, for example, I know 4. I know this 4 is the distance. But this x here inside the absolute value can be or positive or negative. I know this distance, but because I have this, I need to do this. First, I need to take the bars of absolute value. So when I have something like this, I'm going to have two inequalities actually. Why two? Because I'm going to have first x when the thing inside the absolute value is positive, and I'm going to have negative x when what's inside the absolute value is negative. So I need to solve for this and for this. This is already solved for, so I can graph this in a number line, which 0, I have 4 here, and I have -4 here. So x less than 4 is going to be open circle less than 4. But in this case, I have -x. So I need to take the -x away from that. So how can I do that? Well, if I have this, I just need to multiply this entire equation times -1. But remember what happens when we multiply an inequality, multiply or divide an inequality by a negative number. This sign will change the direction, right? So I'm going to have x greater than -4. Why? Because I'm multiplying this times -1. So, okay, this one is already graphed here, x less than 4, but now I need to graph this. So it's x greater than -4. So this is going to be open circle like this. So the solution set is this. So let's do the guided practice more organized. Okay, so here we have guided practice 1a when we have absolute value of n minus 8 less than or equal to 2. So, what are we going to do? Whenever you see an absolute value inequality, you know automatically that you're going to have two equations from this one. So the first one is when what's inside the absolute value is positive, which is basically the same thing, is going to be this. And the second option is when what's inside the absolute value is negative, which is negative n minus 8 less than or equal to 2. So those are my two options. So let's solve this one. So I have n less than or equal to 2 plus 8, n less than or equal to 10. Okay, so this is already solved for n. Pretty simple. But in this case, we have a negative sign outside this. Why am I using a parenthesis here? Because the thing that needs to be negative, it's everything that's inside the absolute value. Inside the absolute value is this expression, n minus 8. So that complete expression, n minus 8, is the one that needs to be negative. That's why I'm using this parenthesis, because this negative sign is for this entire expression. Because it's for this entire expression, I can use distributive property for this negative sign, and I'm going to have negative n plus 8 less than or equal to 2. Why? Negative times positive is negative, negative times negative is positive. Okay, solving for n. Negative n less than or equal to 2 minus 8, because this 8 is positive here, so I move it to the other side, negative. So negative n less than or equal to, this is negative 6. Negative 8 plus 2 is negative 6. But then I don't want negative n, I want n. So I need to divide the entire expression, and now I have to do it in the entire expression by what? By -1. So when I'm multiplying or dividing by a negative sign, this inequality over here will change direction. So it's going to be greater than or equal to 6. So when I'm going to graph that, I'm going to put it on my number line. I have 6, I have 10. So for my first inequality is n less than or equal to 10. So less than or equal to, so this circle is filled, less than that. And then I have n greater than or equal to 6. So this is close, but it's greater than or equal to. So it's going to be like that. So these two meet in here, in this rectangle here. So this is the solution. The blue part is the solution for this inequality, for this compound inequality. And this is an AND type of inequality. Now we have guided practice 1b. In this case, the absolute value is absolute value of 2c minus 5 less than negative 3. So how can we work with this? First, we need to break this into two equations. The first equation will be when what's inside the absolute value is positive. So I'm going to have 2c minus 5 less than negative 3. And the other one is going to be when what's inside the absolute value, which is 2c minus 5, is negative. And I'm going to use a parenthesis again. Negative 2c minus 5 less than negative 3. Those are my two equations. So I'm going to solve for this one first. So 2c less than negative 3 plus 5. This is a plus. So why? This is negative in this side, so I move it to this side, positive. Then I'm going to have 2c less than 2, because 5 minus 3 is 2. And then, to solve for c, I need to divide everything by 2. So I'm going to have c less than 2 divided by 2, which is, come on guys, 1. C less than 1. And now I'm going to solve the second equation. So I'm going to do distributive property again with this negative sign. So I'm going to have negative 2c plus 5 less than negative 3. Okay, I want you to keep in mind something. We're multiplying by a negative number just what's inside the absolute value, this expression, 2c minus 5. That's why I'm not changing this sign direction, because I'm not multiplying this entire expression. No, I'm just changing this expression that's inside the absolute value. I'm changing this to negative, okay? So negative times positive, negative, negative times negative, positive. So I have that. And then I have to solve for c, because this is my variable. So negative 2c less than negative 3 minus 5. Then I have to divide everything by negative 2. Because I'm going to divide by a negative number, now this will change direction. So it's going to be c greater than, okay, negative 3, oh, negative 3, sorry, negative 3 minus 5 is negative 8 divided by what? By negative 2. So my solution is c greater than 4. Negative 8 divided by negative 2, negative by negative is positive, and 8 divided by 2 is 4. So c greater than 4. So number line 1, 4. My first is c less than 1. So it's going to be open circle less than 1, right? This is my first. And then I have c greater than 4. So c greater than 4, open circle. So this is my solution set. This type of compound inequality is called an OR type. Now you have to do classwork, which are going to be these exercises. Left column. So you have 4, 5, 6, 7, 8 exercises. 8, 11, 14, 17, 20, 21, 24, and 27. What are they asking for? Solve the inequalities, then graph the solution cell. By solving, you mean that you have to do both equations, solve both equations by x, for the variable, and then you graph the solution set. There you have it. That is the classwork. So I hope you like the video. I know you're asking for the test that you took last class. Okay, some of you actually got a grade less than the previous one. So for those of you who want me to put the previous grade, you have to look for those tests because I gave them to you, okay? Anyways, we'll talk about that on